Hi, I'm Chris Goschuk. I'm a research geneticist at the Appalachian Fruit Research Station, and I lead our pome fruit breeding programs. And today I'm standing in front of our two original trees of Bell pear. And Bell pear is named after my predecessor, Richard Bell, the previous breeder here at Appalachian Fruit Research Station from 1979 all the way through 2017. This is a release from 2022. It is a long-term breeding program's product, as the cross was originally made in 1984, and some of the pedigree extends all the way back close to 3 generations of breeders behind me, all the way back to our original location in Beltsville and even possibly further. Also, some of the material used in these pedigrees are housed in our national germplasm that's in Corvallis, Oregon. So a parent of Bell is Luscious, which can be found there, which is an old historic variety that was generated, I think, in South Dakota. And this material here generated us a nice fire blight resistant pear. This one is probably one of our most resistant releases that we've ever had, and it's got really desirable fruit quality for direct-to-consumer applications. This is Illinois 76. This is a pre-breeding line developed way back in the early 1900s in Illinois. It's an interspecific hybrid between Pyrus iorensis and Pyrus pyrifolia, and it has been a breeding line used extensively in the New Jersey breeding program in the 1940s, and now still carries on tradition here in its pedigree's usage in a lot of our breeding material. But we maintain this tree, and we hope to back it up in Corvallis, our gene bank. That way we can preserve this one's unique founding history for providing fire blight resistance to our breeding program and to other breeding programs in the US. So this is a clonal copy of Malus fusca PI 589975, which is the germplasm accession that we utilize for our transgenic breeding program, where we're hybridizing Malus fusca with our rapid cycle lines. We also sequenced this one's genome, and it is now the reference genome for this species, which is a native wild apple to North America. It exists in Northern California to southern Alaska. This is a cross between Malus fusca, and this cross was with a rapid cycling line that we have here at AFRS. And rapid cycling is a transgenic system where we have a gene that allows the plant to flower and fruit very rapidly. So that way we can go through a generation in 2 years as opposed to 5 to 15 years that we typically see with apple. So this cross with Malus fusca has a goal of transferring genetics from Malus fusca, particularly a resistance loci for fire blight, into backgrounds of Malus domestica, which is our cultivated apple. So using the rapid cycle system, we can harness the genetics of this wild species and transfer it through practical breeding methods into new backgrounds that could potentially have new resistance to fire blight, our major disease.
Back in the 1800s, Luther Burbank was breeding pitless plums. So he had found a mutant that did not have a pit, and he started producing plum seedlings to have plums that you could eat just like a snack. They wouldn't have any stone inside. So that material, unfortunately, has been lost. However, one accession was found by a private breeder and sent to the germplasm repository. And about 15 years ago, we obtained that, and we started working with this trait again to try to once again revive this concept of developing pitless plums. And this is some of our breeding material. This is all from the original accession from the germplasm repository. That individual is also used for our plum genome sequencing, which is the first complete sequence for Prunus domestica, the species of plum. And we now have a huge variety of pitless plums that we've been working with, and we're trying to understand why they're pitless so that we can hopefully move that trait into other stone fruits like cherries, where the pits would be a real problem, and it would be a tremendous boon to the industry if they had seedless cherries.